Dream machine. .com, HL7, IHE, and Snap. We're building the future, never looking back.
Hey everybody, welcome back to Imaging Informatics Unplugged. I'm your host, Jason Eagles, and today I have a guest that I have genuinely been looking forward to getting on the mic since we crossed paths last year at SIM. My guest today is Satvik Tripathi. Satvik is an incoming medical physics and imaging informatics PhD student at the University of Pennsylvania, and he has been working at the intersection of AI and radiology since 2019. That's 7 years in a field that's changed a lot more in those 7 years than most fields have changed in a generation. He serves as the AI scientist for RAD-AID International, where he is working on Google-funded foundation model deployments in Botswana, and has previously led AI scoping work in India. He's been involved with RSNA and SIM in meaningful ways, and he contributes to research on LLM benchmarking, prompt engineering, agentic AI in imaging, and making radiology reports actually readable for patients. He's also someone who's not afraid to call out the hype, which makes him exactly the kind of guest that I like to have on this show. And before we dive in, if you're getting value out of these conversations, hit subscribe, like the videos. It genuinely helps more people in the imaging informatics community find the show. And if you're working towards getting your CIIP designation or want to build a stronger foundation in imaging informatics, head over to nagelsconsulting.com. We have our part 1 of the CIIP Foundations program and an upcoming DICOM training program with hands-on live imaging learning labs that I think you're going to love. So with all that said, let's jump into the conversation. Well, thanks for joining me, Satvik. I really appreciate the opportunity of you coming on Imaging Informatics Unplugged. And we met last year at SIM, and I love these opportunities where you get to meet new people in the imaging informatics community. It was our mutual friend, Amina Elahi, that put us in touch. So that was kudos to Amina. I really enjoy watching what you're posting about. You're very AI focused on LinkedIn and share a lot of different papers that you're involved in. I think we're going to talk about that. Maybe just tell us where you are in your journey right now, academically, and what you're pursuing. And I'd love to hear about why you got into this particular area.
Yeah, sounds good. And first of all, thank you for having me. Shout out to Amina for introducing me to half to the field. But I am currently incoming medical physics engineering PhD student here at Penn. I've been working in AI in medicine, or like radiology specifically, since 2019. This would be the 7th year, which sounds like a long time, and the field has changed quite a lot. Back then, I used to work on, if you remember, the ResNet models or chest X-ray. That was one of the first things I touched. And now we're all into the space of agentic AI, large language models and vision language models. That's kind of the realm I'm in right now. A lot of my research focuses on workflow optimization, stress testing these foundation models that are coming in, and doing a lot of global health and seeing how we can bring AI to a lot of the low middle income countries and even to resource constrained settings.
You've been at it for 7 years, 2019, AlexNet 2012. So we've had a few years. The industry has really identified that there's something here. Is that what was catapulted you in this particular direction?
So actually I was, this is like high school, right? So I was at the Stanford Summer Institute, and I was there in an AI course. And then this is right about the time Dr. Kurt Langlois, he came in and gave us a lecture. And that was a defining moment for me, and I always tell Kurt like that kind of just changed the trajectory of my career completely, because it was really fascinating, because we were in that course for like several weeks. And I was like, wait, everything that I learned can be applied to an actual problem that can help people. Just that thought alone. And this is right around the time of like Chexpert and NIH releasing their huge data sets. And there was a huge boom in that area. So that is where everything kind of started.
And you are involved in a lot of different things. Before we turn on the mic here, we were talking a bit about your involvement with RSNA and the podcasts that are there. I know you do things for SIM. I'd love to hear you talk a little bit about the work that you do with RAD-AID, because you just mentioned democratizing the care that we have across the globe. I've been honored enough to get to help out with RAD-AID on a couple different missions, and it is very eye-opening when you see the disparity in one location versus another. What have you been doing at RAD-AID in your capacity?
Yeah, I think global health is a huge part of what I do. So I'm originally from India, right? So I know the differences in the health system and the health communities. And with RAD-AID, I serve as the AI scientist for all of RAD-AID. I help with any AI problems. But right now, I'm working on a Google grant that we got to work on Botswana and help deploy their foundation models, MedGem, and kind of evaluate them on how we can strategically use, especially in radiology settings. So that's kind of where I am with RAD-AID in the present capacity. But previously, I worked on projects in India where we scope out health system and the capacity building and seeing what's available and what's need to be done if you're deploying AI safely. Global health was one of the reasons why I pivoted towards medical physics as well, because if you look globally, there's a acute shortage or none medical physicists, in these low resource settings. So that is a big plan for the coming years to work on.
Mm-hmm. I remember one of my trips to Nepal, that was a RAD-AID mission. There, I forget the vendor that RAD-AID had partnered with, but there was a chest model, and it was pretty amazing seeing it in operationally being used in a clinical setting where it would output a PDF encapsulated DICOM object of whatever the result was, with an indication for the physician to look further, and seeing that in real time in a resource constrained place it's very impactful.
Yeah. And, I always believe this, that in the US, we have a lot of constraints. And when we think about adopting AI and even just like testing it. But when you look at the adoption and the application of AI in resource limited settings, you see the value coming out. Like when we talk about RVUs, like you see real RVUs in real time increase in workflow. And that is fantastic. And you learn a lot. I feel like from a governance standpoint, or just like, looking at safety checks, teaching. I think all of these things you can learn from global deployments and bring it back to US. So
yeah, it's interesting. I'm based in Canada, but same type of constraints. It seems like sometimes there's a very good solution or a good opportunity, but privacy is always going to put up some breaks. You'll always have some sort of governance policies and checks, and it sometimes feels like these things, take a very long time, whereas it is really impactful when you get to see this in operations in a clinical setting. I'd like to hear what your thoughts are. You've been sharing a lot about AI research and how it focuses on model performance. So what does it take to move on from this model performs well to what is actually having an impact in patient care?
Yeah, I think that's a fantastic question, and often a question that's overlooked, at least the second part, that we have fantastic research community that is working on various model developments, and these models are performing exceptionally well, 98%, 99%, and, they have great, demonstrations of performance. But like, if you take a step back and if you think of two things, where is this model going to get inserted in the workflow? Very exactly. What tools is it going to utilize? Where would it sit? Is it going to sit on-prem? Is it on cloud? Where in the system is it connected with RIS, PACS? Is sitting inside the EMR? Where is it? Thinking of these things. And then second, asking who's interacting with it and what is the need of interaction, right? Is this even needed? Or is this just another, pop up on the screen? And if you just think about these two questions, it will solve half your problems, right? It's like you have a fantastic tool, but you don't have the problem for it. So you build the problem for a tool that you build, and then you keep going in cycles. And I feel like in the current environment with so many foundation models and so many GPT wrappers and now various different LLMs, there's so many tools. But then if you think about the actual usability and compare with someone use it beyond a research and a pilot phase, it's hard to imagine at the moment.
And now that we have this opportunity of AI helping with the coding and the development of an application, the barrier to entry has lowered significantly, which can be a good thing. There's an opportunity where someone had a really great imagination, they know of a problem, and now the barrier to fix that problem is a lot lower. but it also creates a lot of noise. And yes, the model performs well, but it creates a significant amount of friction within the workflow and no one's going to use it.
Yeah, and a second thing in that is how you're measuring the performance is also a huge another thing, right? So maybe the way you're evaluating the model is kind of biased. And so maybe on a particular data set or particular way that you're evaluating the model is performing 98%. But as soon as you introduce more variables and more real world cases, it drops down to 60%.
It's interesting because our discussion about serving global health and serving other demographics and other communities, well, it speaks a little bit of what, when you validated something on a particular, like pick Kansas City or something like that, and you have a demographic of individuals that isn't going to necessarily match Nepal or Ghana.
Exactly. I mean, a very good example, this is like early days. One of my professors used to give this example is that way back when the CNNs just hit the ground, there was a research project, I think in Russia, where they kind of wanted to do image classification to civilian versus like military vehicles. So all day long, they're taking pictures of the vehicles. They took all the pictures in the day. They went around taking like motorcycle, cars, all the civilian vehicles, and by the end of the day, they took pictures of the tankers and all the military vehicles, like big buses. Performed great, 99% accuracy, and something very good. And then as soon as they deployed it, the model went down, plummeted to like 40% or 30%. And people were like, wait, what just happened? And when they investigated it, it turned out that all the civilian vehicles were pictured in the day. All the military vehicles were pictured at the night. But now, just due to the brightness of the pixels kind of is what the model was predicting rather than, civilian versus military vehicles. We don't even think about it. And, we have constantly heard this thing that AI can look beyond what humans can see, which is a problem too. That if I can see a bias, I can't help, so there's a very extensive need to do stress testing to find out where it's actually learning from.
I had a conversation with Woojin a while back and we were talking about this, and he shared that, no radiologist on earth could look at an X-ray and determine the race of a patient.
Exactly.
A model can. However, it's seeing something that the human eye is not picking up. And so what does it do with that information? And down the pipe, is it perpetuating other stigmas and racial bias and down the road?
And it's a bigger concern now, right? Bigger models coming in play, like these foundation models, which are trained on everything and anything. We just don't know the distribution. We don't know the exact process of training. It's very hard to think about these biases and how do you even start, right? Yeah, it's a very important field and something we're trying to tackle.
You have shared a lot about oncology, and within oncology, it's an interesting service line that is very image focused, where you have imaging that is specific to oncology. You have pathology, you have radiology, you have all clinical records, treatment response. So from your perspective, when you think of oncology, where does it fit in when it comes to being an important proving ground for clinical AI?
That's the hope, as I get done with medical physics, go into residency. I definitely see a huge future for AI in the clinical onco space, not just on the physician clinician side for us to use, but also on the patient side to look at the patient communication. And I think that's a fantastic opportunity for us. So I'll speak on the clinical side first. I think we have seen early prototypes, I think from Microsoft for the tumor board, for example, where they're able to concatenate different information or different sources of information and try to do like a multi-agent system. I think that is a great start, but it doesn't have to stop at tumor board. I think there's a lot of communication between various specialities, different roles within the treatment planning to support team to techs. All these different communications can really be streamlined with the help of AI and, generating reports and making things more systematic, doing reviews of the priors. It's really, but like in RAD-ONC, like specifically, right, treatment planning, just checking the overlays, contouring, organ level segmentation. These are tasks that can be automated over time and, reduce the cognitive load on the clinicians. On the patient side, I think we have the opportunity. I mean, in the literature, we have seen how AI can help reduce the complexity of the medical text, the reports, whatever summaries you're getting and make them more patient friendly. Even make infographics, right? Tess and I did a paper with CHOP on making pediatrics text more accessible and making infographics using GPT. With Dani, I did a study on making radiology reports more accessible and making them into 6th to 7th grade level summaries. And in our evaluation with non-clinical volunteers, they loved it. Like that was like almost like they were able to like dissect which is coming from a true radiology report and what's like a summary report designed for patients. And that's where there's real value. And not just in the States and Canada, but also in like low middle income countries now when there's models that can do translations. And it's great, One of the big challenges, if you think about it, here at least, you can call up your nurse and you can call up your physician, you can call up your PCP, talk about your report, discuss your report. I don't think everyone around the world has that accessibility to do that. So it's very important if you think about that infrastructure modifications that you get your printed report, but maybe you also get half a page of explanation what this report means because you're going to wait a week to 2 weeks to see a physician again.
I believe it was Chuck Kahn that had Porter, and this is before the AI boom. And so this was a very deterministic method of providing a lay report to a patient. And so we had a conversation on the Simcast. I think it was Dr. Teresa Carreras, and she went through how Porter works. It's just fascinating to see in such a short amount of time. We are so far beyond what that work was doing, but still trying to achieve the same root problem.
Yeah. I think root problems never change, right? Like we keep trying to solve the same thing, but we just keep getting more efficient, I think I was at a commencement recently for one of my friends, and the student speaker said, life doesn't get easier. We just get better at handling the harder task. That's, I think, very applicable to us too, right?
You've talked a little bit about LLMs in radiology, and you've raised important questions about benchmarks, data leakage, reproducibility, and clinical usefulness. And it does seem like it's hard to find a PACS or an imaging solution that hasn't tried to build an LLM integration into the imaging application. So what should better evaluation of medical LLMs look like?
That's a fantastic question and something people should ask, I believe, a bit more often because I think Rujan would agree is that we don't throw multiple choice questions very often in a clinical setting. A case comes up and there's four options to pick, right? Or when I'm on a rotation and my attending just asks me, "Oh, Satvik, pick one of the fours." I don't think that's a good way to benchmark models, just question answers. And data leakage is a big problem now that if everything's on the internet and models are trained on the internet, it inherently get trained on the data you're testing on. And then the whole problem of just testing on a training data set, you don't know where the performance is getting conflated. So one thing that we're trying to do and actually building is making data sets and benchmark internally and keeping them internal and testing on that. One problem that I'm still facing, would love feedback on this also if anyone has ideas, but like, how do you make this accessible? Like this benchmark data set accessible where people can come in and benchmark their models on this. I think one way is that you share your model, we benchmark it and give you a report. But I still don't know how, what's the best practices to host it. But that's one thing to think about. The second thing to think about is going beyond what's publicly available and being tested like MedQA. And there's multiple benchmarks. But beyond that, if you ask a good clinical question, and then have a human evaluation on that, like, is it actually working the way it should be working? If not, where is it going wrong? That's much needed, not to prove that LLMs cannot do certain tasks, but to find what can it do good. For example, I recently found out these models are fabulous at creating decision trees, something I did not think about before, but it sucks at classification, at certain cases, but fantastic at decision trees. If I can get a decision tree, I can make a Bayesian-based model to make it a classification, and this is more intuitive, and I have a more accessibility to the results, right? So finding what it's bad at also tells you what's it good at. And then when you use that, you can build something which is more reproducible and more available to everyone else. And then they can, benchmark on that. I think that's a benchmark.
How far have you taken this yourself? Have you hosted the LLMs locally and had bake-offs of different models and to see which ones perform better?
I mean, that is an ongoing project we're working on, hopefully soon release it. But yeah, we have built an internal data set, all humanly annotated, and we have tested upwards of 20 models on this task. And it's fantastic to look at the results. And it's not what you would think the results would look like. And in particular, that the fine-tuned versions are actually not the best performing ones in certain medical contexts. And then that raises the question is that it's not that they're models, it's just the way they were fine-tuned. When you get these findings, it kind of helps you understand where these models are best suited for. Yeah.
Curious when it comes to benchmarking and identifying like how well a model is doing, especially within large language models. We've all used our different chat bot programs, and when it gets something wrong, it is so dramatically alien to how we would get something wrong. If I give you a math problem and you go through the calculation in your head and you get it wrong, it's probably very understandable. I'll see the cookie trail of how you might have got that answer incorrectly. When it comes to the LLMs, we've all heard the one where it argues with you about how many R's there are in the word strawberry. And so what has your experience been in, identifying and also curbing when these types of mistakes happen?
I feel like hallucinations are inevitable in the current scenario. These models are getting better, though, at reducing them with larger and larger context. And I think 2 sims ago, I titled my talk, LLMs, they are, what was it? Never in doubt, even if wrong, something like that. That's what I titled it because, they can be absolutely wrong and make up something and be so confident about it. And that is a big problem. And one thing that I have tried to do now with prompting specifically is make it more deterministic. So if you make sure you're prompting it with instructions. So you can lay down, make a chain of thought, give your steps, give your reasoning, give me the output in a particular structured format, and validate your results, right? So do kind of an ensemble, run it 3 times and give me the best, the median. There are small tricks like that can help make it more reproducible and more fixated towards certain context. And I think that is the key, how you prompt it. And that will reduce the hallucinations for sure.
I was going to go in a different direction, but since you brought up prompting, I'm going to ask a question about prompt engineering. You had a paper that framed prompt engineering as more than a productivity trick. And so it's not just about saving time, but it really speaks to what you were just kind of highlighting, putting some more deterministic values in there. I'd like to hear you expand a little bit more on why does prompting matter for reliability, safety, and responsible use in imaging in general?
Right. If I would say prompting is early days when we did hyperparameter search, hyperparameter search is not just for productivity. Sure, it helps in gain of performance, but it's a scientific method that we apply to get a understanding of where the model is performing the best, what exact hyperparameter tuning it needs to adapt to this data set. When you think of prompting, it's a similar thing. When you say any word, it's a token, which it retrieves. It kind of goes back and tries to retrieve similar tokens, because what LLMs are doing at the end of the day is predicting next word and next token. It produces that based on what you give it. So if you think about it, if you give something, say, was an apple, right? Apple can link to multiple words if you think about it in a word cloud. But if you say, what is a green apple? Now you have defined it further. What's a green apple in America? What's a green apple in Kentucky? So now as much as you narrow it down, you kind of smattering the context that it can retrieve from, and hence increasing the probability of getting it right. The content matters, and that's what prompting's really helping.
It's always a good reminder, that it is just a prediction tool. And when you crunch every word that has ever been composed in a human language and put it down into a GPU, it is very impressive at the quality of information that we are getting back and the quality of responses.
Yeah. I feel like it's like a game of hangman. You're giving it certain clues and you have to just predict the word, and you get certain tries before you say, oh, this model is bad, but it's fantastic. And that's what it really motivates me, because pre-LLM, we were still doing NLP, right? Our
Mhm.
group was focused on NLP for a long time. These models are just fantastic NLP models. I don't know why we forgot about this, or like we didn't think about these. That at the end of the day, these are NLP models that can do NLP tasks. It can extract, structure, and even now retrieve and redefine these texts. Isn't that fantastic on how scalably you can use them? Bird models were hard to train, and just testing them and training them was very painful processes. Now you don't even have to train these models. Like right off zero shot performance is comparable to a BERT model trained on local data sets. Just having that thought is very fascinating.
To digress, if you're loading these locally, what is the experience that you have had using open source models versus commercial products? What has your experience been with open source models within the topic we're talking about?
Personally, like it depends on the use case. Like on a personal level, I do have a cloud subscription. There's certain tasks that just cloud does fantastic.
Mm-hmm.
Then I have local models on my computer, which I have made small packages, basically. If I want to make summary of a paper, I don't like to put it on internet. I run it locally, right? So I don't want to feed it to the internet. And I have made myself smaller, AI packages that can do these things locally for me. I have my own AI meeting notes app, and then I can just use it locally and it summarizes my day. And then next day gives me a checkbox on things to do from the past day, which is fantastic. And these things are so doable with small, like 4 billion parameters model. It's like 4 GB on your computer, and you can easily run it on a Mac now. On the clinical side, it depends on what health system you are in, what compliance level your organization is at. These are important factors. At Penn, we have a HIPAA compliant GPT access that we're using for a lot of the research development. We are also have now started looking into smaller models and open source model to have it behind the firewall to test and try on the internal data. But again, it really boils down to your institution's policies. But in terms of keeping up, I think at this point are at par at certain tasks, at least from what we would want it to do on a clinical standpoint. I think these open models are really catching up, or in some cases even doing much better.
It does seem that this is a very important point that I think a lot of people don't think about is the value of being able to run something locally and not give all of your prescription history and everything up to the cloud. And then, whatever is going to happen to all that information that is there, it's there now. And companies switch hands. You are in a vulnerable spot. But I don't think that is a topic that is, front of center people's minds.
And another thing, like I think you would relate to this from an informatics standpoint. Anything on premise is better. It just makes life easier, right? You can containerize it. You can move where it sits and make it work, right? If you're thinking of deployment, on cloud gets tricky. API calls, rendering time. If it's sitting in certain systems, can it make the call, or it needs to be in a different system and then make the call? Retrieval systems. It adds more complexity. And I think the value at the end of the day comes in like, what is packageable? What is small enough to be used? And then we have to think about the environmental factors too at some point. We're burning up our GPUs all the time for research, but at some point you need to think like, if I just need to, do a small patch fix, I don't think I need a sword. I think I can do just fine with a needle. And that is my thought about generalist models. I know there's a lot of hype around generalist models that one model can do everything. And these are huge models. But then I think about it, do we need to run that big of a model every time for every task? Or can we have just specialized small models like we have had so far and been doing good for us and deploy those? It's more sustainable, more eco-friendly, more cost-effective.
We were talking before the mic went on, and we were talking about your podcast on RSNA, Hot Takes. So
Hot takes.
I would love to hear your thoughts about agentic AI. And so this is a real thing, but it is also every single marketing company is just jumping on this. And there is a lot of buzz about agentic AI that is not really agentic AI. And I also think it's just things that are being pitched in to be agentic that don't really need to be agentic. Where do you see the role of agents moving forward? Where do you see this in imaging and in the workflow?
Yeah. Wow. I have so much to say. Okay. First, like, where are we at? I think there's a lot of hype. There's a lot of hype, and no one is defining agents. No one, like, the definitions are super conflated between what's an agent versus agentic system versus agentic AI, what's a tool, or what is this just multiple LLM system in a chain. There are certain key features you need to have make it agentic. You need to have calls to a tool. It should have iterative processes. It should reflect itself, communicate with various agents, have some level of autonomy. These are key things. So we actually, Vuja and I and Tessa wrote this very good editorial for Radiology in which we just outlined these definitions on what is an agentic system, what's an agent. So I think that's a good read if you're starting off with the field. And I agree in the current way how things are. I think if you walk in RSNA, every second vendor would be like, we have an agentic system. And one of my favorite things is that I just, hide over my badge at RSNA and I just ask, tell me more. I don't know about AI. And you get very different responses, and at points I've questioned, is this even AI, let alone agentic? Um, and that is a problem. And that is something we as practitioners need to take a step ahead and kind of evaluate before diving into the hype is that A, is this even agentic? And B, if it is it working? I see there's huge potential for agentic systems in radiology, radiation oncology, various fields, because there are so many endpoints. And since there are so many loose endpoints, I think we can really aggregate these informations into more synchronized manner. But I think in the current state, it is a big challenge. Our team is also working on agentic AI solutions. And one of the biggest challenges is how do you connect with various systems? Because these are not developed yet, right? A lot of these, you need MCP servers, tool calling.
Mm-hmm.
A lot of these tools are not yet developed. They are in the pathway to be developed. And they will be next 2 to 3 years. But like at the moment, the connectivity is where it lacks, right? And once it's done, I think it would be a fabulous tool. And actually, I won't be there this year, but I do this session called Hip versus Hype at SIM. It was what happened this year. And we're going to talk about agentic AI and we kind of cut through like what's hip and what's hype. Great session to catch, to learn more about like in which direction is the field moving.
I like that. Yeah, it's interesting as well. So as we start offloading some of these tasks to agents, and once agents start interacting with other agents, we lose a bit of the control of why a decision was made or why a certain direction or choice was made. The opportunity of these two agents to be able to come to a consensus on a particular path or a decision forward, we're losing more visibility as to why that happened.
And this all loops back to prompting, right? If you're prompting it right, it should be, printing out reports and logs every time it interacts. If you're prompting it right, you can actually go back into the JSON files and find exactly where things went wrong.
So I wanted to ask, so I'm curious about this because I have heard that the chain of reasoning that you see displayed is not necessarily representative of what is actually going on in the background. And so while it says I'm going A, B, C, D, it's really going A, B, W, Z, B, and then it finally gets to D.
Yeah. And actually, I was in a meeting earlier, and this is the exact question I brought up, is that not that these models are great at thinking and reasoning, do we want to prompt it with a chain of thought? This is where it diverges. If you don't do its chain of thought, it has its own reasoning thought, and then it becomes less accessible to understand how exactly it went to the conclusion it went to. If you make a chain of thought, you are providing it a particular thought process, and then it would just follow that trend and trajectory. It would be able to give you step-by-step analysis, right? So it would have to follow A to B to C and not go to W or X.
I'd like to give you one last chance to just share closing thoughts. And
one thing that's I've been involved in and I want to keep pursuing it is stress testing these models, not blindly just following the hype, testing it for myself, keeping my judgment of what I've learned and judging from that perspective, seeing if the models are actually doing good. What is it doing good in? and then using that task in a sustainable manner, working on my prompt engineering methods, learning it every single day and trying to make it better. And just like verifying the results before I put in. And one key thing for every researcher, I want to say this, like, as someone who reviews a lot of manuscripts, we should not let go of our research practices that we had. I think having a hypothesis, having exact methods, what you did, doing still statistical analysis on the results you're getting, these are very important things that we should not just let go of. Like, even though if it's an applied science or implementation science, that would be my biggest takeaway.
That's a interesting one in the sense that my daughter right now just finished first year university. Skill degradation is unavoidable if we lean on tools too heavily. It's just a
I
matter of
had
time.
undergrad who, they're like, how do you do literature review without deep research? I'm like, PubMed? You go through, it's like, oh, wow. Yeah. It makes you feel old.
That's funny. Well, maybe that's a good way to leave it here. I really appreciate you coming on. Maybe, I'm sure it won't be the last time. We'd love to have you back on some time in the future.
Yeah, this was fantastic. Really, thank you for having me.